Okay, so let's start by talking about the two main types of waves. So you have electromagnetic waves and then you have mechanical waves. So electromagnetic waves are different kinds of light. And so the different kinds of light that are in the electromagnetic spectrum are represented on that picture there over to the left. So starting with radio waves, and then you have infrared. Another name for infrared light is heat. Then next to it you have visible light. Then next to that you have ultraviolet light. And then next to it you've got X-rays. And then finally you've got gamma rays. So all of these are different kinds of light. They all travel at the speed of light. And we're going to devote more time on this in future lessons. So the other kind of waves are mechanical waves. So a mechanical wave is going to require something moving in order to transmit the wave. In the case of electromagnetic waves, you do not. So you do not need to have anything that is going to be carrying the electromagnetic wave. So an electromagnetic wave can go right through outer space. So mechanical waves, an example of a mechanical wave might be an earthquake wave. So an earthquake wave, the S and the P waves travel through the earth. Okay, you could also have a surface wave, like an ocean wave, could be transmitted through a liquid. And then you've got sound waves, which can be transmitted through the air. So waves can be transmitted through solids, liquids, or gases. Okay, another way of describing waves is, are they longitudinal, are they transverse, or are they surface waves? So let's start off with the longitudinal wave. And for this, it's best if you have a slinky to actually do this demonstration so it is more concrete in your head. So if you want, you can pause me right now and then go to the internet and then find a video that says slinky longitudinal waves. So just go ahead and find like a 5-second video that shows how this happens. Okay, so hopefully you watch that. And so the idea is you take your slinky and you stretch it out, and all you're going to do is give it a shove. So on one side of the slinky, you're going to do this. Okay, and what that's going to do is it's going to make a compression in the slinky that is going to travel down the slinky. And so that's going to be a longitudinal wave. All sound waves are longitudinal. Sounds like a good test question, doesn't it? So sound waves are longitudinal. Okay, then you have transverse waves. So again, find a video that shows this. Okay, did you watch it? All right, so this time you stretch out your slinky, but instead of giving it a shove, what you're going to do is you're going to give it a shake like this. So let me rotate my slinky around like this so it's going towards you. And now I'm going to take the thing and I'm going to go like this with it. And then that's going to make another pulse that is going to travel down the slinky, and then that one's going to be called a transverse wave. And so all light waves are transverse. Okay, but think about an earthquake wave. So it turns out that you can have longitudinal waves that travel through the earth, and you can also have transverse waves that travel through the earth. And so these are going to be called, the longitudinal waves are going to be called the P waves. You have heard of that. And then the transverse are going to be called the S waves. Then you have a surface wave. So in order to have a surface wave, you've got to have a surface. Now, that means a boundary. So a boundary between two different substances makes a surface. Now in this picture here, I've got ocean waves. So the surface would be at the boundary between air and then water. And then at the interface between the two, you could have a surface wave. But in the case of an earthquake wave, you could have surface waves inside the earth. So in the case of inside the earth, you know that in the earth you have different layers of rock. And so as an earthquake wave travels through the earth, it might set up a surface wave right here at the interface between this rock layer and then this rock layer up here. So I just want you to know what a longitudinal wave looks like, and then be able to give me an example of a longitudinal wave, and then do the same thing for the transverse wave and then the surface wave. Okay, and then another way of thinking about waves is in terms of, is it a traveling wave or is it a standing wave? And so for this, I have a PhET simulation. So if you go to the internet and then go to PhET and then go to wave on a string, okay, then you're going to find this simulation right here where you can take this wrench and you can move it up and down. Okay, so a traveling wave is going to be a pulse that travels down the wave. So if I take this wrench and I very quickly move it, so let me move it down and then move it back up again. So down and then up. Okay, you can see that it was generating a pulse that traveled down the rope there. And also, did you notice what did it do when it got down to the C-clamp over here? So let me do it one more time. Okay, did you notice that it bounced off of the C-clamp and it went back towards the wrench? So that's going to be called reflection. So in the same way that your image, light image, can be reflected in a mirror, this would be a mechanical wave that can be reflected off of this C-clamp. And then also, you should have noticed something happened to the amplitude. So the amplitude was the height of the wave. So the distance from here down to here, that was called the amplitude. So look at what happens to the amplitude as the wave is traveling. Okay, you should notice, let me do it one more time here, down and up. Okay, so you should notice that the amplitude is getting smaller the further away you get from it. It's getting weaker. And so we'll explore that in a little bit more detail in another segment of this video series. Now, that was a traveling wave. Now, if you take the wrench and you move it up and down at just the right speed, you should be able to set up a standing wave in the string. Okay, so what does a standing wave look like? So it only is going to occur at certain frequencies. So the first standing wave, so let's say that this is my wrench over here, and then here is the string, and then here is the wall. So the first standing wave is going to look like this. So let's see if we can get one standing wave in there. So it's kind of hard to do this, but if I take this thing and I start moving it up and down, if I'm doing it at the right speed, okay, can you see that there is like one gigantic wave being set up in there? Okay, then the second standing wave is if it's going to look like this. So it's going to go up and then down, and then it's going to go up and then it's going to go down like that. So that's going to be two standing waves. So now notice what I'm going to need to do with the wrench in order to get two standing waves in there. Okay, so kind of hard to do. I'm going to let you do this at home to get that right. But if you're doing it at just the right frequency, you should be able to get two standing waves in there. And then what do you think if you want to get 3 standing waves? Can you draw 3 standing waves? And then can you predict how fast do I need to be moving the wrench up and down in order to do that? So 3 standing waves then is going to have 3 of these things in it. And I'm going to have to do it at a higher frequency. I'll need to move the wrench up and down at a higher frequency. So theoretically, there's no limit to the number of standing waves that I can put in there, but there is a limit on how fast I can move my hand up and down. Okay, so that was an example of what a traveling wave looks like. So in this picture here, this first line represents what did the wave look like when you first click your stopwatch. And then after a certain amount of time has gone by, this one here has turned into the red one. And then after another moment in time has gone by, the red one now turns into the blue one. So you can see that the wave is being transmitted down. And now this picture over here, it's kind of hard to see, but this is a person up here who is sitting next to the rope. And then here is 1 standing wave. Here is 2 standing waves. Here's 3 standing waves. And then here's 4 standing waves. Now, in a future lesson, we're going to learn how to actually calculate the frequency that is going to correspond to each of these different kinds of standing waves. But we're going to do that later. So I just want you to see the difference between a traveling wave and a standing wave. Okay, let's take a break, and when we come back, we'll talk about how to describe waves.